Hi everyone, welcome to the Huawei Developer Group UK. This is the first event of the HDG and we're super excited to have you. My name is Enzo and I'm an Android developer based in London. I'm also a community organizer, and since we're running the Kotlin meetup for the past 4 years. So I'm not the only one running the HDG UK, because as you can see, there's another organizer. It's Ricardo. Hi, Ricardo.
Hey, Enzo. So, well, guys, thank you everyone for joining. My name is Ricardo Diaz. I'm a full-time machine learning engineer in CGG, geophysics company based in London as well. I'm also part of the GDG community and HDG communities. And I'm looking forward to see you join to this amazing HDG community we're building alongside with Enzo.
And actually, Ricardo will be the host of this event and explain why in a moment. So what is the Huawei Developer Group? The HDG is a network community that are all over Europe. The community is in Spain, in Italy, in Germany, who are passionate about new technologies. The aim is for developers to explore and learn the Huawei Developer Kits, but also provide a platform for exchanging the knowledge, not necessarily tied to Huawei. So we hope that this community will become a hub for learning new skills and improving your knowledge. So we hope that everything will run smoothly, but since it's the first event, forgive us if there will be some small hiccups. So if you haven't done it yet, join our meetup page, subscribe to our YouTube channel, and follow us on Twitter. But also, if your friends or colleagues might be interested in watching us, or even giving our talks, we are open for getting new speakers, especially new people who are actually getting into speaking. There's always like a room for everyone. QA will be done for each talk. For the first talk, it will be after the talk. And Giovanni will talk about his Q&A. You can post a question in the comments. Please ask us at the hashtag with the hashtag ask, so we can know which is the question and just comment. But if you also just want to say a thumbs up or hi to the speakers, or just a well done to the speakers, feel free to us to do it. We do it online. It's helpful for the speaker to have some feedback and know they're not just talking to the void. So that's all for me. I'll leave it to Ricardo, who will introduce the topic of tonight, which is machine learning. I know nothing about machine learning because, as I said, I'm an Android developer. I'm very keen to learn new stuff, but that's why Ricardo come and save us. Go on.
Awesome. Thank you, Ansa. So today we're going to talk a little bit about deep learning with KotlinDL and also some machine learning superpowers, with HMS and ML Kit. So first, we're going to have Alexey, who's going to join us from JetBrain. Hopefully, Alexey will join us soon. And we'll learn a lot about how we could use these new tools that KotlinDL and also HMS ML Kit can give us to work with this amazing machine learning tools that we're building today. So yeah, we'll see what the amazing things it brings us. Yeah. Okay. So as you can see here, hello Alexey, how are you doing?
Hi guys. So I'm happy to join you join your event, and in a few seconds I think I will share my screen with presentation, and we will go to the deep learning with KotlinDL. This new library developed totally in Kotlin. So give me a few seconds to share screen.
Yeah. So it sounds quite interesting. I'm actually very keen to learn about this as well, to maybe implement some in my job. So yeah, quite exciting. I might have some questions at the end.
So I will wait your question. Yes, I don't want to be interrupted during the session, but at the end I will have a time to answer all your questions. And please, guests, attendees, please type your question in the chat. I will answer. So, did you see my screen, Ricardo?
Yeah, it's all there.
So,
it's all good for you. So I'll leave you here for.
Great.
Yeah.
So, cool. Let's go. I think that many of you know the Keras library, which runs on the top of TensorFlow, and know what is TensorFlow, heard something about PyTorch, and etc. TensorFlow itself has a stable API, C API, and therefore there are several high-level deep learning frameworks in other languages inspired by Keras, such as TensorFlow.js. Maybe somebody used this in the browser. Maybe Keras.net project. Maybe somebody heard this. TensorFlow in Go, it's used to in Go ecosystem. And today I want to introduce you to a Keras-like machine learning framework written in Kotlin. Currently, the KotlinDL framework can boast that this is the only way to construct and train complex neural networks on JVM, such as VGG, ResNet, and MobileNet. There is also support for transfer learning for the popular models trained in Keras, or maybe available on the Keras.applications page. There are a lot of different models there, including exception, efficient.net, and so on. And we started a few weeks ago the implementation of different models for computer vision from this page. For image preprocessing, several functions are available that allow you to avoid complex and routine work on the JVM. For example, maybe you don't know, but JVM has no one stable, good preprocessing library for images. There are a lot of them, different, maybe unfinished, and we provided yet one based on the low-level graphics 2D objects, manipulations, like maybe famous library image scalar, but now it's abandoned and we couldn't use it in the modern preprocessing. And this was the reason why we integrated a very minor model in our library for image preprocessing, because doing it manually, it's too hard and painful. So finally, I'll show you how you can build, train, and use convolutional neural networks like CNN, maybe very different in architectures, entirely in Kotlin, with the help of our framework. And maybe we will touch in some points how to use KotlinDL models in production now. So let me introduce myself. I'm a Java and Kotlin developer for the last 2 years. So I'm started in this work like a distributed ML enthusiast. Started my work from writing special distributed ML model for the Apache Ignite in-memory database open source product. So after that, I became a TensorFlow contributor. I started my contribution to Java API of TensorFlow, for core TensorFlow, and so on. After that, I joined to JetBrains as an ML engineer, but not as a researcher, but like a framework writer. Also, you could follow me on the GitHub, on the Twitter. You could follow different projects related to my JetBrains activity, or maybe to my Apache activity, all of them related to the ML frameworks, different ML frameworks. So I want to say a few words about motivation, why we started in JetBrains develop different tools for machine learning, for data science, etc. In last 2 years, Kotlin took a course to become a convenient language for data science. We started from the Let's Plot framework for visualization. After that, we wrapped Python library NumPy. But it was a temporary solution. I mean that at this time we decided to remove the Python layer, which gives us a lot of overhead. And now we are trying to invent new library for multidimensional arrays in Kotlin. I will talk about it later, some words. So no modern data science today without neural networks. I think you agree with me. All deep learning frameworks are good enough at image recognition, and this was the reason why we started from this domain, not from audio preprocessing or maybe from famous GANs. So we started from the convolution neural networks because a lot of tutorials how to start from this, and it could be a first step for newcomers, for newbies who started in Kotlin, learning maybe deep learning, maybe switches with stable model from Keras to continue his experience with stable models provided by Keras. So training, transfer learning, and inference are now available for different CNN architectures on Kotlin with KotlinDL library, and today I will provide some information about it. So KotlinDL is a Keras. You could see on that today like an Keras framework, but written in Kotlin. So Keras, in reality, what is that? This is a TensorFlow C++ runtime plus low-level Tensor API plus Python high-level framework with layers and models. But for example, a few years ago, it was very teeny layer of Python code which wraps the low-level C++ runtime. I mean TensorFlow 1, where there will be a lot of different low-level operators, but then Keras project with friends actually joined to the Google, and it was merged to the main code repository. Now we in many cases thinks about TensorFlow like about low-level relatively Keras API. So we remove the Python code. Imagine we remove a Python code from here and rewrite a part of that in KotlinDL. Not exactly the same, not every string. This is not the goal of our framework, but the high-level API is the same, and some internals calculation is too close to the Keras and give the same results in many cases. So perhaps wrapping Python is difficult and painful, and we reject this way. We have such ability in Java or in Kotlin to wrap the Keras framework, but we had a painful experience with wrapping of NumPy, and we decided to start it from zero to here. So from the very beginning, there was a low-level Java API in the TensorFlow main repository for inference, and it was marketing like an API for inference only. But 2 years ago, I found very strange undocumented classes which was in the repository and which gave us ability to train simple models, and not only simple models but very complex models on the Java API, a low-level Java API. It was undocumented. It was not published on the TensorFlow site. It was very strange, but it was the entry point for our research and for our library now. So how it works? Somewhere in the depths of TensorFlow, there's a C API, as I said, and it's suitable for generating bindings on the top of it for all the programming languages, including Java. Kotlin has a full interoperability with Java, and we could use all these classes which could be generated. Also, Java has a special technology which could help to call C functions on the Java side. It means it's famous like a GNI technology, and we can generate so-called native methods in Java. So in our case, these methods were generated located in the main TensorFlow repository, and it reduced our work on wrapping. So after that, you can already build a Java API of varying degrees of complexity, and sometimes this is done by hand. For example, I saw a lot of projects where guys trying programming method by method, but there are a lot of, I don't know, a few hundreds of low-level operands and TensorFlow API, and it's very difficult to wrap all of them in the same manner. So in the case of Java API TensorFlow, hundreds of classes for all sorts of operators were generated by a special C++ class. Now in the new version of Java API, it's rewritten with Java, but it was this C++ which generates 4,000 classes in Java in the same manner. So in any case, this low-level API also comes with TensorFlow and is developed in close cooperation with Google, and it's enough stable. So, and at the top of this level is the Kotlin code level, which provides the top-level building blocks for creating and training neural networks, such as activation functions, weight initializer layers, optimizers, loss functions, and so on. And TensorFlow operators are used to implement these building blocks. But in the future, for KotlinDL, it's planned to switch maybe on the PyTorch operators when we will wrap the special part of our PyTorch C++ front end with these operators, or for example, with some of our with some guys from other teams, we are going to write some custom kernels implemented using our multidimensional array library Multic, or maybe the NVIDIA libraries like CUDA, JCUDA, and so on. Maybe it will be our own kernels. We don't know. We have a lot of experiments here, and the performance, the final performance for us is not very critical at this moment. But I think that in the future it can be changed. So the possible future could be this, like on this slide. I'm sorry, I'm not a designer. I create this picture from the different rectangles, but the architecture in future could be like on this slide. We could have the same Keras-like API and bind with different runtimes via GNI and Java, with OnNX, with PyTorch, with TensorFlow, or maybe with alternative libraries if they will have a C++ or C API. Maybe JAX from Google, from DeepMind will have this kind of API in future, and we will wrap it too. Why not? So I want to say a few words about our ecosystem for Kotlin for data science, because I want to invite you in our ecosystem. Don't forget about Python, but try to taste some interesting things in Kotlin. So first of all, we released our multidimensional array library for Kotlin. It has Kotlin pure implementation and native implementation with OpenBLAS under the hood, and it could achieve the comparable performance with NumPy, the multi-native implementation, I mean. But for example, the JVM implementation on the pure Kotlin could be executed on Android. We are going to release support for Android for multidimensional arrays during this year. I think it will be available for different interesting things on the Android side, and maybe in the future release, it became maybe you know the multi-platform library. It will be available, for example, on iOS, on the Android side, on the JavaScript, the same API, the special technology for Kotlin. You write on Kotlin, and it's available and compatible with different languages. So, but it's very experimental technology, and I think it's too early to say how it will be in the next year, for example. Also, we have bindings for the Apache Spark project for distributed training. So it provides Kotlin idiomatic API, type and dimensional safe for different Spark operations. So also, this project adds a missing layer of compatibility between Kotlin and Apache Spark. Apache Spark has Python, Scala, Java, R API, but the Kotlin wrappers for Scala looks ugly, in my opinion, in my humble opinion, sorry. And it was the reason why in the team, the Pavel Filkestein wrote a wrapper and the idiomatic Kotlin. So also we had a data frame library in progress. It's not the copy of Pandas library. It has special, of course, Kotlin idiomatic API. You could do the same like in Pandas, maybe more Kotlin idiomatic way. So and also it includes a few new operations which could be used by users in different use cases. I think it will be released soon in next month possibly. So also at the end, last but not least, let's plot library for visualization. It's multi-platform and can be used not only with JVM, also supports JavaScript usage and Python usage. For example, you could take this library to the Python ecosystem and use with different Python libraries on this side. So also, it's wonderful, but it works together in Jupyter Notebook, and not Jupyter Notebook, if you know, supports different kernels for different languages, and now it's very, very interesting to mix them together, not only in IntelliJ IDE, but it supports the Kotlin kernel too, which is open source project that brings Kotlin support to Jupyter Notebook, and it has a lot of pluses for using with strong typing languages with different auto completions and etc. and so on. Please try Kotlin DL with Jupyter Kotlin kernel with Jupyter Notebook. It's a very interesting experience. So why was Keras taken as a sample, which is more and more often overshadowed by its competitor PyTorch? I will answer you. So the fact is that they developed in different ways and under the influence of different ideologies and interest groups, in my opinion. So while researching our potential audience in the Kotlin community, we came to the conclusion that we are closer to the ideology of working with neural networks offered by the Keras framework. What does it consist in? So the Keras API philosophy, from the last words of the Francois Chollet, creator of Keras, progressive disclosure of complexity. Progressive disclosure, from the Wikipedia definition, is interaction design pattern often used for making application easier to learn and less error-prone. Imagine macOS UX. It does that by differing some advanced or rarely used features to a secondary screen. You should start from the very limited set of features and go deeper step by step. So I stole this slide from the Francois Chollet presentation. Sorry, Francois. What ordinary users want? Those users who are not deeply immersed in the mathematical foundations of deep learning. I thought about that a lot, but who want to use its capabilities on a regular basis, maybe developing the backend and mobile applications. I think it's maybe not ordinary users, but engineers, practitioners, and etc. But what we want, we asked our audience. They wanted best practices baked in by default. For example, best initial values, best activation functions, and so on. Don't think about that. Don't use the hyperparameter tuning. They want as little code as possible. They want easy logging. They want clear explanation exception. For example, from my experience, then I started my work with TensorFlow low-level exceptions. It was very, very, very strange text in all of them. You really couldn't understand what's happened. There's something with shape, something with tensor, something strange with C++ API, and we are trying to replace this strange exception parse part of them to create very clear explanation. What's happened? Then you compile your model. What's happened? Then you're trying to fit. Maybe make some tips for the users. What should be improved in his model to get better results, and etc. I think a few tips could be taken from the Andrew Karpathy tips how to train neural networks, and it could be very useful for starters, for newbies in deep learning. Also, KotlinDL contains a lot of examples, I think, for all use cases, which is possible with this library, and you could easily copy-paste to your project and start. So users with advanced engineering skills whose destiny is to roll models into hot productions like hot potatoes, prepares an infrastructure for experiments, and quickly tune ready-made models to suit their needs. What do they need? I thought a lot about that too, and we explored our audience here and asked a lot of questions, and engineers answered that they wanted flexible model architecture, a lot of building blocks which could be easily joined together, flexible training logics which should be hidden from the practitioner, transfer learning, of course, because they don't want to train the models from zero to hero from scratch, yeah, but take the ready model and maybe retrain the last layer, the last dense layer with a few neurons to fine-tune the model loaded, from example, from the Keras applications. They wanted transfer learning, of course, and different export and import for ML ops needs to different systems like ML ops, for example, I'm sorry, as ML flow, for example. But what about researchers who are giving birth to the new models? We have a double trouble with researchers. They don't want a framework in our research for researchers. They don't want a framework. We want just a toolbox with low-level control of every detail. They want a custom gradient loop and be able to add new components on the fly. And on the start of development of our framework, we need to decide for what audience is the main for us. And we decided that we will work, first of all, with basic users and with practitioner engineers, but not with the researchers, because we are using runtimes from PyTorch, for example, from TensorFlow, and we need a time to adapt new technologies, new neural network architecture, and so on. And what opportunities does KotlinDL give now? I would say that it's more focused on the basic users, as I said, and in the next releases, we will make KotlinDL more open, I think. It will be possible to add your own custom components, such as an activation functions. It's very small component, loss functions maybe, layers, optimizers, and initializers. But I'm not sure that we will delegate the full control on the training cycle, like in PyTorch or different new modern frameworks for researchers. But for now, you can send us a pull request, for example, and new developments will be included in the next release. I promise you, every layer, every new initializer, and maybe every new optimizer. But it is hard to add new optimizer now because we are limited by the TensorFlow runtime. So as I said, if we look at the model training from simple to arbitrary flexible, at the current moment, KotlinDL provides the model fit method for quick experiments and provide callbacks. I know that, for example, in PyTorch Lighting or in Catalyst framework, it's now the time for adding the callbacks, because PyTorch has very strange experience. Basic PyTorch has very strange experience with callbacks. I don't remember exactly. Maybe it's not included in PyTorch now. I mean basic PyTorch, but it's available on the high-level frameworks, which was inspired by Keras, maybe. I'm not sure about PyTorch Lighting. So also, if you are a researcher and you want to be experienced researcher written in Java or in Kotlin, if you need a low-level manipulation JVM, you could use a Java API for 1.x or 2.x TensorFlow runtimes. But I have one note for you. Java API for 1.15 is stable and fast, and we are based on this runtime. It doesn't influence on interoperability with modern Keras. We could load model from modern Keras from model TensorFlow, but we are using previous runtime because it's faster in many cases. But Java API for 2.x is under development and has a few performance issues related to the garbage collection, but it's ready for experiments, and I think all models will work, but maybe you will take a few memory leaks. Don't use it in production yet. There are a few useful links here on the slide, and you could find here a few of my articles about how to write, for example, LeNet 5 on the low-level operands. It's close to your experience how to write the same on the Python, but the naming is bigger with this. So let's talk about KotlinDL features. I told a lot about ideology, about ecosystem, but let's go to the features. It's very short list. So the previous release alpha release supported sequential API. It's very simple API. You stack layers in one line. So, and you can build only VGG-like sequential models like VGG 16, like VGG 19. So it could be exported from Keras. You could download these models, with their weights, and make transfer learning on your side, for example. Also, previous release supported training on TensorFlow, for example, for classification and regression simple models and for VGG-like models too. But no interesting residual connections and etc. and etc. But the upcoming release will bring to us. I said upcoming because the alpha version is available on Maven Central today, but I think that the stable version for it will be available in next 2 weeks. So the upcoming release will bring to us at once several significant groups of features on board, and I'll start with the first and most important one. The so-called zoo of models is available, which includes a special loader of configs and model weights for each of which the original data preprocessing is available. Applied during training on the ImageNet dataset, it's very different. For example, MobileNet trained with one type of preprocessing, ImageNet, I'm sorry, ResNet version 1 with alternative type of preprocessing. All of them are available in Keras applications model, and we moved the same. We wrote the same preprocessing on the Kotlin side too, because it's very important to preprocess new data for transfer learning, for example, in the same manner. So the next new things, the addition of new layers, which are required for building ResNet architecture, MobileNet architecture, is batch norm, activation layer, deep-files and separable convolutions, different merge layer to merge your different branches in the model, all 7 of them which are available in Keras. It's global average pooling, the new replacement for the last dense layers, cropping 2D, reshaping, zero padding 2D. It's not exactly all the layers which will be available in the final version of 0.2 release, but I think the most of them. So also it includes embedded data sets which are located on our servers, but it could be downloadable via different simple functions like MNIST, Fashion MNIST, Cephar 10, and famous, maybe somebody remember, dogs versus cats image data set from Kaggle. I started from this data set a few years ago. My way in deep learning, I think it's very interesting to retrain your last layers in your model with a few images from this data set. For example, if the pre-trained model was trained on the ImageNet, I think that cat and dogs are compatible with the ImageNet images. So also, the next group of features is, as I said, the image preprocessing. We have a special Kotlin DSL for image preprocessing with supporting of crop, resize, rotate, load from the directory and saving to directory operators, also rescale. It's very important operation too. And for example, the basic augmentation, we have no augmentation library in support yet, but the basic augmentation could be realized easily with our DSL manually, for example, for your needs, if you need augmentation for training on the real huge data sets. Also, we have different data sets. The reason that traditional way to run data through the neural network in forward mode is to load batches one by one into RAM and then into the memory area controlled by, for example, by the TensorFlow computational graph. We support this approach with on-the-fly data set. He sequentially, during one training epoch, loads batch after batch into RAM, applying the pre-processing described in advance if it was defined. For example, you could miss this step. But if our data fit into RAM, for example, we have 100 gigabytes of RAM or 1 terabyte, let them load and keep all this data in RAM. Why not? Without reading it over and over from disk at each epoch, it's like a caching into your RAM memory. For example, on-heap dataset is your choice for this use case. So, of course, like all new frameworks, it has a few limitations. Now it's useful for image recognition task and regression ML only. For example, you couldn't train task from speech recognition domain, for example, or maybe new cool modern style guns. But I think it's in future it will be available too. It has limited number of layers, and at this moment it has no Android support. Sorry if you joined this meeting thinking that this is a Kotlin for Android and you think it about this to this moment. It's Kotlin for backends. By our polls, 1/3 of users used Kotlin for backends, but I think that at the end of this year, we will provide a few wrappers for working and maybe training for TF-Lite format. You know, this is special, highly optimized format for TensorFlow, and not only TensorFlow models on the mobile devices, and maybe if PyTorch will improve his own mobile formats, we will wrap it too in the after working with TF-Lite. So KotlinDL roadmap, I highlighted a few moments from this, but especially I need to say that in the following releases, we will add new models to the model zoo. Inception, very famous model; DenseNet, not so famous; EfficientNet, and maybe if the Keras framework will provide in applications EfficientNet version 2, or maybe new NF nets without batch normalization. We will add this model in our model zoo 2. Also, I'm going to add a special tunable GPU settings, because now it's very hard to tune the fraction of occupied GPU memory, for example, in KotlinDL. Also, a few missed things in our framework. It's a regularization for all layers. Sometimes it's very interesting techniques which could improve your experience with neural networks. New metrics will be added. Also, as I said, conversion to TF-Lite format in Kotlin, not in Python like now. Also, we are going to integrate on NX and PyTorch runtimes also. Maybe if you're interested in it, if you know, for example, Kotlin, very good, or Java, we will have a separate project, a separate model in our project to create different ML, classical ML algorithms like decision trees, linear regression, etc. in Kotlin, and you could join us to add more new algorithms when basic interfaces will provide it after a few months experiments. So is it time for demo? I have not so many time, but I want to share my IDE to run a few simple models because I want to demonstrate you how it could be written in Kotlin. So give me a second to share my IDE. So I hope you see my screen. Just a second to check. Yeah, I see that you see my screen. So here we in the simple project which named KotlinDL demo. It's available on GitHub too. I will share links in the presentation for the organizers, and they will share review. So here we see the simple iris dataset. Maybe do you remember 3 classes, simple classification task, 4 features. 4 features for every of that, and we could build very simple neural network input a layer with 4 neurons because we have 4 features, huge dense layers with 200 neurons, activation function, kernel initializer, bias initializer, and the final dense layer with 3 neurons because we have 3 classes. This is the model description in Kotlin. So here we need to shuffle our data, prepare it in just an array, and create the on-heap dataset because it's very small. tiny data. So we need to split data set to validate on the tests subset, and we could go deeper with our model. All these steps may be familiar to you if you have experience with Keras. You need to compile the model, to compile the underlying TensorFlow graph. You need to set up the optimizer, loss function, and metric. I will prefer accuracy metric for classification tasks. After that, we could print the summary of our model, all layers. I will run model to check this, and we could start the training. We are calling the feed method, where we could pass the link on the train data set, the number of epochs, the size of batch, and we could evaluate our model on the test subset and calculate accuracy. The final accuracy is enough high, but if we will revisit our model, we will see a lot of neurons. I think it was learn all training examples here, but don't worry about that. With the logging, I use standard Java logging for this model. This is, for example, log4j logging, described with XML file. You remember this technology? This is that. So this is simple console output. It could be outputted to the file, for example, to the database if you want, and etc. We have 3 simple layers. We have number of parameters. So different stats about batches, about our epochs. It prints the stats not like the Keras. You remember this special line. We change from second to the second, but we work on it. So the next example is the training, the simple LeNet. The difference is in the model description here. So if we will go to the training model, it's the same. We compile the model with alternative optimizer, where we clip in gradients by the value. There's the same loss, there's the same metrics, and the same code of training. I think that we could imagine the easy method. Then after definition of model, we could call only one method, train, with default settings. So the model definition is the following. We define the input. To define the input shape of our data on MNIST dataset. For MNIST dataset, we call the special function MNIST, which loads the MNIST dataset for us and put is in the special cache folder on our disk and the special subsets. You could replace this path to your custom path if you need, but by default it will be downloaded to the cache dataset NIST, and all the famous images in the ubyte format will be loaded here, will be located here. So also the LeNet has convolutional layers, max pooling layers, again convolutional, max pooling, flattened layers, and dense. No new things. I think should be very, very familiar. Maybe, I don't know, the formatting of code is different. Maybe from the Python experience and from your Java experience. But the difference is the strong types. For example, you could go to all these variables have types, and all are building block have types, and it's very easy to program. Also, as you know, the IntelliJ IDEA has auto completion. It's very easy to code these models, these model definitions. So also we will go to the production ready example with ResNet 50 model. It could be loaded from the model zoo located in the same directory cache/pretrained models. You could choose the model type, which should be downloaded. For example, you could download it VGG 16 or MobileNet version 2 if you want, but we will stay with ResNet 50. It loads the configuration of the model, the definition of the model in JSON format. For example, you could find it here. This is model JSON config. This is a totally Keras description of the model, and we support this format because in future we want to be able to train our models, for example, in KotlinDL, load them to Keras if you want. So also the weights in H5 format are loaded too, and you could compile your model with anyway losses because it doesn't influence our prediction, and preprocess the data with special preprocessing DSL, preprocessing pipeline. We need to define loading from the resources directory. Here a few photos. For example, this is me, but younger in 2 years, and a few images: pigeon, cat, broccoli, no, tree, I don't know, car, strange fish, which reminds me nipple, sorry, brown beer, and really goldfish, like on the 6th page. Let's see what will be predicted by ResNet 50. The top 5 labels will be printed. So this is a lot of loading H5 sets. It's debug messages. It could be disabled, of course, by our settings, but let's check. On the first image with young me, it was found jersey, lab coat, tube, hand blower, sunglasses. Okay, but not the real man. Okay, so Petrich, Veteros. Okay, it's close to the pigeon. I'm not sure about the real type of this animal. Egyptian cat, exactly the same. It's Egyptian cat, sports car, broccoli, not real tree. Agree, this tree reminds me broccoli too. Goldfish was found on the 6th image, and brown beer and goldfish on the last image with different degree of accuracy, but was found too. So, but if you want to really transfer learning, not only for prediction, but if you want to retrain something, you could try to get the initial model, for example, to load it from the model zoo, describe the pre-processing. For example, I want in this sample, I want to retrain the last layer on the cat docs small data set. Only 1,000 images per class in this data set is subset of the whole cat docs images data set. And I want to resize all these images because they have very different sizes to the input of our neural network of ResNet 50, and after that I want to remove last layers. This is a code to remove last layers. We need to remove layer and remove all boundary lines with previous layers here, and we could add in functional API manner new 2 dense layers. For example, we've named top dense and prediction, and create the functional model from the last layer. It's close to the Keras functional API, but we don't need an input here because it will be found automatically. So we will compile the new model with optimizer, losses, metrics, like in the previous examples, and we could load weights only for the frozen layers of the previous layers. For example, all of them were frozen by default, and only 2 last dense layers will be retrained from the random initialization. And please look at the screen, just a few seconds. And we will check, we will evaluate new model before. We will evaluate it before training. The accuracy before training only 42%, but after our training, it will achieve more higher accuracy. Just a few seconds. Oh, okay.
Hey, Alexey.
It will achieve.
Yeah.
Oh, sorry. Yeah, the time.
Yeah. So we're running a little bit of time. Yeah. So, but it's quite good. Yeah. It was quite exciting. I think it was 90% accurate. 98. Nice. Nice.
Okay. We'll show only last slide if you give me a second. Only last slide with links. But as I understand, we have no time to answer the question, or we will have time.
No, I think we are running out of time, but you still can post questions in the comments, and you can respond right there in the YouTube comments.
Okay, just a second to share screen. Yeah, I will take more time than decided before. Sorry for that, guys.
It's fine, no worries.
Yeah, just a few useful links. I want to say a few last words. Please follow us on the GitHub, start this project, support us. If you want, you could search all of our Kotlin data science ecosystem. You could join our Kotlin Slack to the deep learning or KotlinDL channels. There are a lot of different mathematics channels there. Join all of them. Join our discussion on GitHub and follow me. I will post new news about that on Kotlin for Data or on Zalislav Twitter. Okay, thank you for your attention, and we'll wait attention layers in KotlinDL.
Awesome. Thank you, Alexey. Thank you. It was quite good.
Okay, I will answer in chat. You guys, thank you for your question. We'll go to the chat.
Yeah, sure. Definitely.
I can stop sharing my screen, right?
Yeah.
Okay.
Awesome. So, well, thank you so much. Now we're gonna jump for our next speaker, Giovanni. So he's gonna give us a little chat about machine learning superpowers with HMS and ML Kit, straight from Huawei, a developer advocate. So we're quite excited about knowing the news and what Huawei has for us to play around with deep learning. So here with me is Giovanni. Giovanni.
Hello. Thank you for having me. Yeah.
Hey. How you doing?
Good. How are you? And welcome to this event, HDG. I'm very excited about it because it's the first actually in UK. We started in other countries in Europe, but yeah, let's go UK. Let's see.
Yeah, let's go UK team. So yeah, you can start sharing your screen.
Let me share my screen. First, I want to thank you also, Alex, for the presentation. No problems if you already ran out of time. It was an interesting one. So let me share my presentation. Here it is, the first slide. Yeah. So I guess you can see the HDG screen, right?
Yep, it's there.
Perfect.
It's right there.
So yeah, let's start. So
awesome.
Yeah, first of all, I already said hello to everyone and welcome. And today we want to show you about some news feature from the Huawei developers. So how to keep your apps, your mobile application, the superpower thanks to the machine learning. And yeah, because with machine learning, you can actually make your app do awesome things, and you can create some innovative feature with it, and you can support a lot of feature that you can only imagine in your dreams. So a little bit of presentation. I'm Giovanni Laquidara. I'm Huawei developer advocate, like we already said. And I have a background as a software engineer, mainly in Android development. But I'm really super passionate about VR and AR and machine learning. Why? Because I think this will be like the next computing platform. So the next base for all the kind of technology innovation that we will see in the future. And I also like to share my knowledge in meetup, articles, and conference, and so on. So first of all, I want to take a step back in respect of the previous presentation. So, what is machine learning? Why we have to use it, and how we can easily use it? So, I want to start from the beginning, and if we can see from this article in 2011, there was this article from Mark Anderson, a famous investor in Silicon Valley, that say that software in that time was eating the world. So all the services, all the companies at that time were about to be heavily impacted by software development, by software application, and new innovative software services were about to spawn, like Facebook, Groupon, Skype, Twitter, and so on. So a software revolution. Today, we say that the software ate the world, but AI now is eating the software, because things that previously were too hard to develop, too difficult to code, like for us, like human developers, now we can make it possible with AI and machine learning. So machine learning. But we sometimes, as common developers, have to do the job of code an algorithm, and we are always used to like do if and else, and so sometimes we are learning about machine learning. Okay, yeah, but it's something that it's just a big set of if else. It's something that we can actually develop. It's only a number of times big and big. In reality, it's not. So this is the main definition of machine learning. So what is machine learning? Is the study of mathematical models that can, given some input, they give some output, but without being explicitly programmed to do so. So it's a complex things, but it's more mathematically than development side of thing. I love this picture about machine learning, taken from a book that I really like, and on machine learning with scikit-learn, Keras, and TensorFlow. And in this picture, it's like it's contain the sense of what is machine learning actually. So you have to define a model and train this model with some data that's coming from the top. And then you have to evaluate the solution because you had a problem. You build this model with the data, and then you will actually have some value that will compare will compare actually with these numbers if the solution is solved by your side, is quite acceptable or not. If it's not acceptable, the solution that the model proposed, you have to analyze the error. Then you have to study the problem again, and maybe you have to train the model with new data. Maybe you have to redefine the model, or maybe you have to adjust and clean the data. So this is like a little resume of what machine learning is. But we as developers, and especially as mobile developers, what we can do, I need to learn totally new stuff, totally new things, totally new books and video courses about machine learning to start using it. Yeah, actually you should, but you can actually use some API that helps you to support the most common model training services that come from machine learning. So yeah, by the way, you can stop me every time with question. I'm happy to answer. But so if we take into account the API that many companies are offering to us as a humble mobile developers about to use machine learning, we can think about Firebase ML Kit from Google, Amazon Amplify, Microsoft Azure that has offers some feature for machine learning. This is like these companies, these products are offering some SDK, some API that we can integrate in our mobile apps, and they are always based on well-known feature like, I don't know, image recognition or real-time translation, sentiment analysis, and so on. So the things that we already used to be used to. And sometimes they are really hard. I mean, not hard, but medium hard to configure. You need some configuration to do because you have to like set some web cloud console, some parameter on that console, and then you have to configure some configuration file from your application integrating this SDK. So it's not it's not straightforward, but it's a medium hard solution. What is offering Huawei? Huawei is offering Huawei ML Kit. This is as an SDK that is part of the big world of HMS core. So the overall services for to offer to you as a developer is a really big set of features that you can integrate for your apps. And in particular, this machine learning kit is offering to you innovative feature, because we will see in a bit it offers a lot of features that were not taught before. It offers you a familiar API if you are coming from the world of the mobile development. So you have not to study a new book or a new video course about all new API. And it's not forgetting also the old Java world, because I mean we are supporting Kotlin, but we are also supporting code sample API Java-based code. So we are not forgetting about it. ML Kit, like I say, it's offering a lot of text and image recognition feature, and it's in constant development because we are always improving the model and all the feature. It's actually working on all the Android devices, not only the Huawei, because somebody of you can actually think, oh, but it's working only on Huawei device. No, it's working on all the Android devices. You just need to have the version of Android greater than 4.4. But the funny thing is they also support iOS for some feature, like text recognition or real-time translation. We are also supporting iOS, but we are working to improve the support of this platform, iOS, also for other features as well. If you go to the documentation website of ML Kit, I will send you the link later. You will see all the features that actually this kit is offering. It's actually optimized to run on devices with low resource optimization. So like it really have a great respect of the battery of your phone or your devices. It doesn't need actually the cloud. I mean, you can run all the defined model, all that API inside the device. So if you need to face a problem like privacy issues, so you cannot send the data into the cloud, no worry, because ML Kit support machine learning on the device. But if you need more power, or if you need some feature that are improved from the cloud API, you can actually use our cloud part of ML Kit. It is also super optimized to run, obviously, on Huawei devices. It supports all the Android devices, but it's super optimized because Huawei has the control of the device, on the Air device from the cloud. We set from the chip to the cloud. So it's like Apple is doing with iOS. We are actually optimizing all the software kit for the Huawei devices. You actually can define model, also your own model, and deploy it on the cloud, but also on the device. And we can start to see some feature, like we have a big chunk of text-related feature. In here, we have like the text recognition. These are like the one that we are used to work with, right? If you already know some ML Kit API. So we can scan and recognize ID card, recognizing the text in images, and define what are the and identify what are the fields inside an ID card. We can do like general card recognition and bank card recognition as well. So this is actually a really good feature, a powerful feature if you need to develop some mobile apps that is asking the credit card from your user, and without the user giving the user the hassle to put all the numbers in a way. But we also are offering something like the form recognition. So you will be able, using ML Kit, to recognize and return the form structure, so the column and the cells of like an Excel file, and then you can actually work with the coordinators, so with row a column file. So it's actually pretty good if you have to decode this kind of file with a camera. For the text-related services, we have a demo. So you can, if you want, you can scan the QR code on the slide, or you can go to the GitHub page of the HMS core, and you can download the HMS core demo. And there is also the code that you can navigate and check to be inspired for your application. And now we'll see like the bank card recognition feature. So like I say, this is actually taking into account the camera. I mean, using the camera for your smartphone, you can point the camera to the card, to a credit card, a debit card, and then it's this SDK is able to recognize the number, the expired number, and so on. Then with your app, you can process the number and do what you want. So it's like a superpower, but yeah, it's a superpower. It is very hard to. Is it very hard to use? No, it's actually to use the bank card recognition. You just need to define a callback that express what you want to do with the data that are coming from the ML Kit. So like the numbers, and then you have to fill the unsuccess, on cancel, on failure, on deny the methods. So to be handled by the callback. Given this callback, you just need to, we are talking about the 100 word, you just need to start the activity that will launch the actually BCR, so the bank card recognition. And then this activity will start the camera for you, and and after the camera will identify a bank card, it will actually call the callback with the data that you need. So plain and simple. Next feature that we are offering is the language voice related services. So all the sets that is covering the language, and so we like detecting the language of a text or a voice, like transcribing audio, or like I said, real-time language detection, text-to-speech, so the opposite, that is offered on device and on cloud, audio file transcription. But even one of my favorites and innovative feature that we have is sound detection. What is sound detection? So sound detection is actually the possibility to identify some sound that are not related to the talk, so the speech. They are not word. Let's see how we can use it. So just instantiate a listener, and then the listener will actually the two callback like we want to use. So if the detector will receive a successful detection, so the detector will hear something, you can take the data and you can use it. So actually, like we saw with the bank card recognition, it's plain and simple. Only if there is some failure, you can handle it with the on-sound failure. But what we can actually decode with the sound detection feature, we can decode up to 12 feature, up to 12 sound. Like we can detect the loafer, the loaf, so the baby is crying, a man that is snoring, a man or woman that is snoring, the sneeze sound, the screaming, the meow of the cat, the barking of a dog, the water is running, the car horn sound, the doorbell, the knocking on the door, fire alarm sound, and a generic alarm sound. This is actually pretty good if you need to develop some pretty interesting application. I wrote an article 1 week ago about how to create an Android application that is like a baby monitor. So it's actually detecting to you when the baby is crying and doing some action. I was using Java Compose for the Kotlin friends that are watching the event, and the ML Kit sound detection. So this app was actually detecting the baby crying, or even the knocking on a door sound, and was actually presenting to the screen an icon related to the sound. But you can you can launch whatever event you want, like a notification to maybe the parents, or maybe, I don't know, play some music to make the baby calm. Again, this could be a really nice feature to offer from your to your user. And it also, don't forget that it's working on the Android devices. Then we have the quite common image-related services, like you can do some image classification, object detection and tracking. So with your camera, you can identify some object and then you can recognize them. We have landmark recognition that is capable to support the recognition of like monument or common place that is really good for a travel company application. Then we have product result search, so it's able with the user could be able to look for products that are similar to the one that is pointing at with the camera. And another powerful feature that is the document skew correction. This is actually really cool because it's, if you with your camera, if your user with the camera is pointing a document that is like tilted or is not in exactly perpendicular to the screen, parallel to the camera of the devices, actually the camera and the algorithm that is running inside ML Kit can modify and transform the document the picture of the document into a plain one. So without, like you were saying, like if you were reading a 2D document, super powerful. And we also have some super resolution feature. So if you are pointing the camera to an image that is with low resolution, the ML Kit is able to try to build an high definition picture of that image. And we also support table recognition. So like I said before, you can recognize table and actually detect what is a table from the camera and take all the data from it. And yeah, and also we are offering a demo for that, and you can scan the QR code to play with that with all the feature actually ML Kit has. Like in this slide, we will see we can see like the object detection tracking. So this is actually detecting some object, and it's also tracking with the camera. It's not identified now, but you can also activate the identification. And then we have like the image segmentation that I want to talk about also. It's like if you need to develop some image editor application in which you want to give your user the power to select the object inside the image, like ML Kit is able to do it. Like it's able to identify plant, animal, even person and hair of the person. So you can actually you can develop. Your fantasy is the limit, or your sky is the limit for this kind of application. Then we have another powerful feature that is the face and body related part of ML Kit. So we have the quite common face detection and the skeleton detection, the liveness detection, hand gesture recognition, and face verification. So with face detection, we are able to detect a face. And actually, you will have like, I remember, up to 855 points per face. So it's a really high number of features for a face, and 14 points for a body. So if you need to develop some application that is doing something, some feature, depending on what the body that is pointing the camera at is doing, like, I don't know, yoga application or games or other medical application maybe, or health and fitness application, you can use this feature. And also if you need to have some, if you want to have some application controlled by the gesture of the hand, you can actually use it, because we are supporting also the gesture recognition of the hands. Like we can recognize the like, but even other gesture from the hand, and even like liveness detection that you can use to create a sort of smart login of your application. So to check if the user is actually the one that is authorized to access the app with the liveness detection, but it's not only a picture of the user; it's actually the real user. So it's a 3D scan of that face, of his face. Here in this code, you can see like the API to use the ML Kit body pose. So pretty simple. You just need to create an analyzer and pass to that analyzer the actual configuration that you want to use. Like I want to detect the skeleton, and is giving the ability to detect the skeleton points corresponding to yoga postures. We have it. It's actually enumerated and you can use it. And then we have, if you are not satisfied with all these features, but because you need a custom model for your kind of apps, you can actually use it, your model, and you can upload the model into the device. You can use the API the ML Kit is giving to you to interact with your model. But if you want, you can also deploy your model to the cloud and then make it downloaded and use it if your client has connection, or you can revert back to the app model that you have inside your application, inside your device, if there is not connection. So this is a pretty good feature, and this is integrated well with the App Gallery Cloud Console, where you have to upload the model, and then you also have the possibility there to convert the model in various formats. Like if you are coming from Onyx, you can actually translate the model into one that the ML Kit can actually understand. If you want to use all the power of the ML Kit, you can study the documentation, but you can also use the HMS toolkit. That is like a plugin of Android Studio that we are developing, and it is available at that URL, but also you can find it from the marketplace of the plugins of Android Studio. You can install it, and then you will have the coding assistant, and then you will see the part about AI, where you can integrate all the API of ML Kit. Is helping you with sample code, really useful. And also you can use that HMS toolkit to train your custom model if you want to do some custom image recognition. So you need to only to upload to the HMS ML Kit some image, and then create your category, and then a little bit of training. After a little bit of training, it will create a model that you can straight away use into your application. This is like the official sample, taking into account that if you want to explore all the features, you have to go there. So the GitHub HMS Core, HMS ML Demo. And also there are other applications that I created with just my fantasy, like a word search solver. It's I don't know if you know the word search game, but it's like it's a game where you have to looking up characters table for words that are composed by characters in vertical, horizontal, diagonal way, and then you have to look for the word. And if you go to that GitHub URL, you will see the code that using ML Kit is allowing a user to scan a table of a word search game and look for words that are based on a dictionary. And plain and simple, it's a little bit of game solver. Really cool. But now let's see how to integrate with the HMS ML Kit into your Android application. What you need to do? The basic stuff of the Android development. So first of all, you need to add the dependency lines of the Maven of the Huawei repository. So like this, just add the Maven lines. Then if you this is in the project build.gradle file. Then into the build.gradle file, you have to add the HG Connect plugin, and then here you can have in the build.gradle file of the app, you can have the dependency of the specific feature of ML Kit that you want to use. Like in this case, I wanted to use the face 3D model recognition. Just add the line, and that's it. And also, don't forget to put at the bottom the apply plugin of the HG Connect if you are using the network services from ML Kit. So if you're using the cloud, you have to use that one because it's related to all the part of App Gallery Connect. If you are not using, you don't need it. Then I created other samples about using this ML Kit and integrated with common Android application. Like in this sample, I was using the new Android API Camera X with the face recognition and the hand recognition. So at that URL, you can actually check out the project and check all the related part of the code that you are interested with. And we are also offering a brand new feature that is like the digital person. This is not strictly related to the Android development set of feature, but it is an innovative one that will give you the power to create a virtual human, like I said. A virtual human based on the video that you have to provide before. And this virtual human, it could be really useful if you want to, for media presentation, for MMOC courses or ads, and so on. Maybe for the future, we can have a speaker that is just a virtual human. And that's it. I mean, if you want to use the feature, you have to contact us because it's still in closed beta, but it's really, really powerful. And and I suggest you to the first QR code to start to play with all this. That is like register a Huawei ID. It's in the developer account. So with this, you can access all the power of the App Gallery console, and you can also access the forum, write whatever question you want in the forum. You can interact with other developers using these services. and we are supporting all the main channels to me and my team to address all the possible questions you will have using the ML Kit, but even other kit that we are offering, and we will talk later in the future maybe. And so we are supporting Reddit, GitHub, Stack Overflow, and other XDA, so a lot of forum. So yeah, I think I did pretty fast. So thank you. And if you have any question, yeah, just drop them here in the chat.
Yeah, awesome. Thank you, Alexey. With Giovanni, sorry. Yeah, so Giovanni, thank you so much for your presentation. I think it was quite interesting. I think that having that human digital will not make mistakes on names, so it will be quite accurate instead of me. Like having a host like that, it will be nice. But yeah, so since that's a different feature, I think people have to contact. So yeah, the contact number will be somewhere on the slides. Hopefully, you can share your slides with us, and maybe we can share it with them.
For sure, I will share the slide. Yeah.
Yeah. So I don't see questions in the chat, but I have a quick question for you, since I'm a machine learning engineer as well, and I just wanted to know if if I have like a previous model that I trained myself, and I have it in I don't know, TensorFlow or PyTorch, would I be able to deploy this into the HDG ML Kit as well, like if I had it previously? Yeah.
Yeah, if you actually have your model from that you already trained with TensorFlow, you can use our tool to translate it on model that is supported by HMS ML Kit, and this tool are offline and online. We are offering both the features, so you can upload it on the cloud or the Gallery Console cloud, and then there will be some translation for you. And when the model will be ready, you can use it straight away. Or if you want some offline tool, we are offering also that one. So yeah.
Oh, okay. Yeah. So quite interesting. You could also already use your own models and put them inside the device, and it will be optimized, especially for Huawei devices as well. So it's quite cool, quite interesting tool. I'm gonna take a look at it myself as well, and it looks promising. So thank you so much for your
thank you
for your time, and it was quite a good presentation. I think we're heading up to the end, and I think Enzo might join us soon.
Enzo, where are you?
Here, yeah. Yeah, thank you so much, Giovanni. Thanks to Alexey as well, who joined us earlier. It was great. I learned a lot of stuff. As I said, so I knew nothing about machine learning now, just a bit. I wish I have time to play with it. Probably in the future we'll have time to do it something and play a bit, especially with the Huawei stuff. Just really, really cool. Bit scary, the human presentation to be fair, but we'll see. We can try in a few months, maybe try to do like a talk with a total like a virtual speaker. Who knows?
Yeah, I mean, there are no like cool interaction with it's like a robot. I mean, but it's pretty cool. But, yeah.
Absolutely.
Yeah, it will do our hosting for us. Yeah, we'll see. Right.
Thanks to everyone who joined us today. It was really good. I hope that everything was run smooth. I had a lot of fun, definitely. If you take a survey, I posted a link here. The link is also in the comments. Please take a survey, share it again on the meetup page later to help us improve. Suggest like new topics and for the next events. We're trying to do events potentially every month. We'll see. We have different speakers, and we're trying to line up new speakers every month with different topics. So thank you again, Giovanni. Thank Riccardo for running the show today, and see you soon. Bye.
Ciao, bye.
Thank you, everyone. Ciao.